Hello and welcome to the web lecture for LSP 120. This lecture covers savings accounts. So for the rest of the quarter, we're going to be spending a lot of our time talking about money. We'll talk about savings accounts, loans, and credit cards. And a lot of this is going to be practical applications of things that we kind of already know. The goal of these lectures is to get you guys to be a little bit more knowledgeable and hopefully capable of managing finances and debt. So we'll start with an example, and let's say your grandma went ahead and gave you $5,000 on your graduation day. Being the smart and savvy student that you are, you decide to put this money into a savings account. Which savings accounts would be the best choice? Which one was going to earn you the most money? We have these three options: 3.2% interest compounding annually, quarterly, or monthly. And so what we're going to explore today is this idea of what does compounding interest mean, and how does that relate to the amount of money that you're going to ultimately earn in that account. There are some terms that we'll talk about. So annual percentage rate, APR, is the percentage of interest that is earned and paid over the course of the year. Compounding interest is the frequency with which interest is calculated and paid into the account. So interest can get calculated and paid into the accounts once a year, 4 times a year, monthly, or we'll see when we talk about loans. Interest can get calculated and charged to you monthly and sometimes even daily. The annual percent yield is the actual amount of money that you earn on that account. It is literally the percent change in your balance from one year to the next, taking compound frequency into account. So we'll go ahead and we'll talk about each of these in turn to see which one of these is going to earn us the most money, the quarterly, the monthly, or the annual. So annual accounts calculate interest, and they pay that interest to account once a year. We are basically doing an extension of exponential change when we think about savings accounts, right? With savings, with exponential change, we have some value that is changing by some fixed percentage, right? We have some balance, $5,000, that's changing by some fixed percentage, our APR, our interest rate. The only real new thing that we're going to be doing is we're going to be adding in a new variable called compound frequency. And so we're just going to be appending our existing formula. We're going to divide our interest rate by C, and then we're going to multiply our exponent by C. So in terms of compounding annually, we could write out this formula, listing out our variables, write out the formula. So the amount of money Y that we're going to end up with is going to be equal to the $5,000 that we started with times 1 plus our interest rate, which happens to be 3.2%. We can convert that to a decimal point 0.032 and divide by our compound frequency. Now, for an annual account, this gets paid out once a year, so we're going to divide by 1. We're going to close parentheses, and then we're going to take this to the C times X power. So to the C, which is 1, times X power. 5,000 times 1 plus the interest rate divided by the compound frequency, all taken out to the compound frequency to the X power, times the X power. Now, for an annual account, as I'm sure many of you are already thinking, why in the world am I dividing by 1? Why am I multiplying by 1? Because, as everyone knows, something divided by itself or something divided by 1 or multiplied by 1 is just itself. And you are right. For all intents and purposes, the formula for an annual account is exactly the same as the exponential change formula. But when we talk about the quarterly account or the monthly account in the next couple slides, you'll see where this comes into play. So if I ask the question, how much money am I going to have in the account after 1 year or 10 years, right? To answer that question, I could simply just plug in, right? I could plug in values for this formula and I could figure out how much I'm going to have in my account after 10 years. We'll say 10 years for now. So we're going to say the amount of money we're going to have in the account after 10 years is going to be equal to 5,000 times 1 plus another open parentheses, 0.032 divided by 1, all to the 10 times 1 power. 10 years times once a year power. Now, again, with the annual account, you don't need to really technically include the C term. You don't really need to worry about it, but this will matter for the next one. We hit enter. We find that after 10 years, we end up with $6,851. Or in other words, over 10 years, we've earned about $6,851. Now, if I asked another question, if I said, how long will it take this account to double in value, to go from being 5,000 to 10,000? Then what we would need to do is we would need to use the table feature to build a table to show us what our account balance would be after 10 or after however many years it takes for it to double. So to do this, we're going to do equal to, and we're going to use the starting value as a reference cell, times 1 plus parentheses 0.032 divided by 1, taken to the first power. I don't really need to do that at this point, so I'm just going to leave it here. When I drag this down, I see same answer as before, plugging in 10 for x. So after 10 years, it's $6,851, and when I drag it down, I get number signs. And somewhere about right here, between year 22 and almost nearly 22 years, just about 22 years, it doubles in value. Cool? Sounds good. So we'll move on and we'll talk about the quarterly account. So, as I'm sure you can imagine, with a quarterly account, interest is going to get paid 4 times a year. So now our compound frequency is going to be 4. So we wanted to know how much are we going to have after 10 years just by plugging in. What we can do is we can say this is going to be equal to $5,000 times 1 plus our interest rate, which is 0.032, 3.2%. But now we're going to divide by 4. Okay. And what dividing by 4 effectively does is the bank is going to take that interest rate and say, okay, we're going to give you 3.2% a year, but we're going to give you 1/4 of it at a time. So in quarter 1, they pay you 1/4 of the interest. In quarter 2, they pay you the second quarter. And in quarter 3 and 4, they pay you the third and fourth quarters, respectively. So in order to make this a full year, then we have to take this out to the C4, and we're asking about 10 years times 10. Right? So if we're going to divide up by 4, we're going to get 4 payments a year. And that means over 10 years, they're going to end up paying us interest 40 times, which is why we have this C times X in our numerator, in our exponent up here. So when we hit enter, we end up with $6,876 after 10 years. And again, if we wanted to ask the question, how long will it take for this account to double in value, we could simply plug in up here for quarterly, equal to starting value as a reference cell times 1 plus 0.032 divided by 4. And importantly, when we do the table method, up until this point, we've always built the exponent into the table, right? By using that reference cell as our starting value, it's going to update every time we drag it down. So that's going to build that exponent in. But we're not building in the C term. So we actually need to include that C term up here in our calculation. And the reason why is that adding this here, dividing this by 4 here, and then doing it 4 times, that's going to get us 1 year's worth of growth. If we left this exponent off, then we've divided this interest rate by 4. Every time we drag it down, instead of getting a year, we're going to get 1/4's worth of interest. If that kind of hurts your brain a little bit to think about, don't worry about it. All you need to remember is that if we divide by 4 here, we have to take it to the 4th power here when we're using the table method. So after 1 year, we've got $5,161. And then we'll drag this all the way down. And again, it looks like it's going to take just over 22 years for this account to double in value. Now, for the last account, the monthly account, as I'm sure you can guess, our C term is now going to be 12 times a year because we're going to get paid every month. I figure you guys can probably I'll do the plug-in anyway. So if we wanted to plug this in and figure out how much money would we have after 10 years, equal to the $5,000 that we started with times 1 plus the interest rate in parentheses, 0.032, divided by 12 this time, close parentheses, all to the 12 times 10 power for 10 years. So beginning balance times 1 plus the interest rate divided by 12, all to the 12 times 10 power. And when we hit enter, we're going to end up with $6,882 after 10 years. We want to do this in the table formula to figure out how long it takes for it to double. We can say this is going to be equal to starting value times 1 plus the interest rate, 0.032, divided by 12, close parentheses, all to the 12th power. And again, when we use the table method, we've got to raise this to the same power as the C term. We have to keep the C here, so we're going to divide this 12 times. We're going to get 1/12 of it over a year. But then to make each row a year, we have to do this 12 times in each row to amount to interest for 1 year. Hit that in, drag it down. We get the same answer as we do when we get plugged in. And then we can drag this down a little bit further, and we'll see how long does it take for it to double in value. Looks like, again, just over 22 years for it to double in value. Now, going back to the original question, which of these accounts is going to earn us the most money? Well, as you can see, looking at the balances here, the monthly account is going to earn you slightly more money than the quarterly, which is going to earn you slightly more money than the annual account. Now, you might ask yourself, well, why is this, right? They all have the same interest rate. And the answer is that compound frequency actually matters in terms of the amount of money that you earn. Because think about what happens in a quarterly account. For that first quarter, the bank calculates 1 quarter's worth of your interest, pays it into your account. And then the next quarter, when it calculates the amount of interest that it's going to give you for that quarter, that 1 quarter of the year's interest, it actually includes the previous quarter's interest in that calculation. So generally speaking, what this means is that the more often something compounds in terms of a savings account, the more money you're going to earn. We'll see in a little bit in terms of loans that the more often something compounds with loans, the more money you're going to actually end up having to pay in interest with the culmination of credit cards, which you will see credit cards tend to calculate interest on a daily rate. But generally speaking, the more often something compounds, the more money you're going to earn. Now, because of this, because compound frequency influences how much you actually earn on the account, banks have a second number that we can talk about called the annual percentage yield. The annual percentage yield is the overall percent change in account value from 1 year to the next. So from year 0 to year 1, or year 1 to year 2, or year 2 to year 3, right? Or so on. It's the overall percent change in account value from 1 year to the next. So if we want to figure out what the APY is for each of these accounts, we can just use the new minus old formula. New, the amount we have after 1 year, minus the old, divided by the old. We hit enter. Now with an annual account, the APY is going to be exactly the same as the APR, because with an annual account, interest does not get calculated and paid out, but more than once a year. With the quarterly account, though, as we'll see, we can drag this over, the quarterly account has 3.24% APY, and the monthly account has a 3.25% APY. And what this number means is that you can expect with this account, this interest rate and this interest rate and this compound frequency, that you will earn, your account will go up by 3.25% every year for the monthly and 3.24% every year for the quarterly. So APY is really useful in trying to determine which account is going to pay you the most money. But what happens when you have accounts that have different APRs, right? We know a couple things now, right? We know that the interest rate, the higher the interest rate, the more money you're going to earn on that savings account. So if your interest rate is 3% and your compared to another interest rate that is 5%, right, you're going to earn more with the 5% account. So the higher the interest rate, the more you're going to earn. But we also know that compound frequency matters. The more often that it compounds, the more you're going to earn. So if we have these two accounts, one compounds at 3.8%, the other one compounds at 3.75%. The first one is quarterly and the second one is monthly. You don't know which is going to earn you more without calculating the APY. And so at this point, I would say, okay, go ahead and calculate the APY. And you might say to yourself, well, up until this point, we've always had a balance, right? We've always had some amount that we needed to, charge interest on or calculate interest on. And so if I don't give you a balance, then what should you end up doing? And the answer is you should make up a balance. I typically like to start with 100, as we'll see for reasons in a minute. So if I start with $100 for each of my accounts, then so if I want to figure out the APY, to figure out which of these two accounts is better, I'm going to start with 100, and then for each of them, I'm just going to increase them by 1 year's worth of interest. So for the quarterly account, that's going to be the starting value times 1 plus the interest rate for quarterly is going to be 3.8%, so 0.038 divided by 4, close parentheses, all to the fourth power. And again, don't forget, we have to raise this to the fourth power to make this 1 year's worth of interest. So after 1 year, I've earned $3.85. With $100 again for the monthly account, I'm going to say this is going to be equal to the amount that we started with times 1 plus 0.0375 divided by 12, close parentheses, all to the 12th power. I hit enter, and I end up with $3 and earning $3.82. The next thing that I can do is I can calculate the APY, which is just the new minus old formula. It's the percent change in account value from 1 year to the next. So equal to new minus old divided by old. And I end up with 3.85% APY for the quarterly account and 3.82% APY for the monthly account. So which account is going to earn me more? Well, it looks like the quarterly account is going to earn me slightly more money. Now, a couple things. Number one, you might already see why I like $100 as a starting value for this kind of question. The reason is that the dollar increase is going to be the same as your APY. So you can see that the $3.85 translate also into 3.85% increase. The other thing to know, if I made up this starting value to calculate this APY, does the APY really depend on the starting value? Does the starting value really matter? Well, we can test this because we've got this set up as a reference cell. So this starting value, I'm just going to change to some random number, and I'm going to hit enter, and watch what happens to the dollar change and the APY. Notice the dollar change is a lot different, right? If you have, $5 billion, right, you're going to earn, a couple million, a couple $100 million on that. But the APY stays exactly the same as it does if it's $5. 19 cents is still 3.85%. So the APY doesn't actually depend on the starting value. We can just make up a starting value and use that in our calculations. One other note about savings accounts before I wrap up. Remember last week when we were talking about inflation, right? If you have money in a savings account, you want to make sure that that money is earning the same rate of interest as inflation. So if you have a savings account with $10,000 in it, let's say, and inflation is 3%, and you earn 3% interest on that $10,000 in that savings account, what that means is that savings account, that money in that account has not lost value, right? That means the value, the amount of stuff that money can buy in that savings account has stayed the same. If you take that $10,000 and you put it into a small wooden box and you bury it at the base of a tree near a rocky wall, and you leave it there for 10 years, right? Every year that goes by where you have inflation, that cash, that physical cash, becomes less and less valuable because prices are going up around it. The cash is not earning any interest in the tin box underneath the tree, and so therefore the value of that account goes down and down and down, or the value of the cash in your mattress or underneath the tree. So when it comes to savings accounts, you really want to make sure that any account that you have is going to be earning you something close to what inflation is. Now, most typical liquid savings accounts where you can just put your money in and take it out whenever you want, especially these days with interest rates being exceptionally low, you're not going to earn anywhere near inflation. But there are some kinds of accounts, money market accounts and those sorts of things, where you can park your money for a bit of time and it will earn you something close to, if not greater than, inflation. So this is it for our savings accounts. Pretty straightforward. We just add our C term, we divide our interest rate by C, and we take it out to the C power. And that will increase our savings account by whatever our interest rate is for whatever compound frequency. The more often something compounds, the more money we're going to earn. The higher the APR, the more money that we're going to earn. So that's it. As always, if you have any questions, feel free to send me an email.